Okay, so you want to know which is greater. Now, in math, we have a symbol for that, so we want to do it symbolically. Is -5 greater, or is the absolute value of -5 greater? Well, in order to answer that question, you have to know what the absolute value of -5 is, huh? And that definition simply says it's the distance between the number -5 and 0. Distance is always positive, so this really, you get that, it really means 5. So now we're comparing -5 to 5. Okay, and that idea of greater than or less than is strictly related to the left of and to the right of. Okay, if it's to the right of, it's greater than. If it's to the left of, it's less than. So in that sense, what we would say is 5 is the greater number, and we would write that with the greater than less than sign this way. That reads -5 is less than 5. The larger part of the sign is toward the larger number, the smaller part of the sign toward the smaller number. So that's the way it would begin. You could write it this way too. You could say 5 is greater than -5. That means the same thing. So either way is fine. Any others? Okay, these are basic ideas. What they're going to let us do is find an eraser. That's what they're going to let us do. Yep. Excuse me. Still yep. All right. I want to take this a little further now. We're going to talk about addition of real numbers. Now we know how to add real numbers. We did it by memorizing tables. And notice our tables are two-dimensional. They're rows and columns. And we would do 1 through 9 over here, and 1 through 9 over here, and then fill in all, 3 plus 4 is 7, and all this kind of stuff. So we memorized it that way. And that's fine. For most purposes, that's perfectly all right. However, if aliens come to invade the planet, and they had three-dimensional tables, guess who's going to win? I mean, it's a very limited form of memorization. In other words, if someone said, I want you to add 3 and 5 and 11. Okay, 3 plus 5 is 8. 8 plus 11. That's outside my table, I'm sorry. But a person would memorize three-dimensional tables, would give you an answer instantaneously. So I don't want us to feel all depressed now and think that we're an inferior race. In this neighborhood of the galaxy, we're pretty good. But, we do have limitations to what we know. What we're going to do now is not only the addition of positive numbers, which we learned from a table, but we want to learn some method of accurately adding positives and negatives, this kind of thing, which we never learned from a table. That actually wasn't done back then because it was very difficult to explain to you at age 7 or 8 or whatever it was, the need for a negative number. If you say, well, your bank account goes negative, they'll say, bank of what? Everything that's negative doesn't make any sense to a person that age, right? Golf scores, what's golf? So, but we know now that we do need negative numbers. We do have negative balances and so forth, negative temperatures and so forth. So we need them. So we want to do something with adding and subtracting both positives and negatives. Now, unfortunately, if you haven't gone through this, there are people who actually try to go right to Algebra 1 when they come to MPC. They talk to the advisors. We had an advisor in here before, Suzanne, you met her. They talk to the advisors, and they convince the advisors that they don't need this basic arithmetic, they don't need pre-algebra. They go right in there. They know what they're doing. And, of course, they find out quickly they don't. In the first 2 to 3 weeks, we cover stuff in that Algebra 1 class that you have already seen twice before, and they have not. So right away, you separate the men from the boys. I mean, it's in the first 3 weeks. Very wise to take this class and the next class, pre-algebra. You can do a lot better when you get to algebra. So one of these things is, what happens when you say I want to add something like 7 plus or minus 4? We don't want a whole bunch of opinions here. Math doesn't work with opinions. It works with precise answers. There's only one answer to that, and it's not up to your opinion. So we have to do something besides that. And if that's not enough, then what do we do with something like minus 3 minus a minus 2? Oh, we would get at least a dozen opinions in this room for that, right? Yeah. All right, don't even bother with it. Let's do it right. Know what you do. Strain your brain on that one. Addition of real numbers. First of all, we're going to look at a pretty picture, the real line. And actually, that's kind of a nice, visual motivation for how it goes. And then we'll have to give up our picture because we can't carry a picture around with us to do addition. Suppose we add two positive real numbers, 3 plus 2. Okay, we know addition means, definition, if you talked about a definition of addition, it would be something like increase, make bigger, increase the amount of, this kind of stuff. So 3 increased by 2. Well, because of the way the real line is structured, you have a 0 there, 1, 2, 3, positives get bigger to the right, and so forth. Same thing actually happens over here. Negatives get bigger to the right also. Minus 2 is considered to be bigger than minus 4. Huh? All right. So because of that, we know we're going to have to start with 3. Just put a dot there for 3. And if it's going to get bigger, we're going to go that way, to the right. How much? 2. So we do a little hopscotch thing. And we end up at the answer 5. Oh, that's cute, don't you think? No. Okay. But let's suppose you get a negative number. Suppose we take out, let's go from a minus 7, and we want to add to that a minus 3. Now, first of all, notice I put the minus 3 in parentheses. Huh? That's something we've encountered before. You don't want two signs next to each other without something in between. That's considered really bad form, so we're going to do that. All right, minus 3 plus a minus 7. Now, what on earth does that mean? Well, minus 7 is way back over here, so we'll start at minus 7. And we want to increase it by a minus 3. Well, increase would be means going that way, doesn't it? But minus 3, increasing by a minus 3, somehow you have to get to the fact that I'm dealing with it adding a negative number. I'm not adding a positive number. Let's start this way. Suppose we went from 7 and added minus 7, add a plus 3. All right. Then you start here at minus 7, and you would go 3 to the right because that would increase it. Okay. 1, 2, 3. And you end up with a minus 4. Okay. With the negative numbers, we're going to have to do something else. And the only other thing you can do, because you only have 2 directions to go in, is if I'm going to add a negative, let's suppose I add 3 plus or minus 1. The only thing I can do is start at 3, and instead of going to the right to do an increase, the only other direction I have is go to the left. So when it's a negative number, I'm going to have to go back this way. And that comes out to be a 2. And the same thing happens over here. If we start with 7 minus 7 plus a minus 3, then I'm going to have to start at minus 7 and go 3 over to the left. And that would put me at a minus 10. It's off scale, minus 10. So yes, that works. The hopscotch thing is interesting if you do the left or right stuff. But it's not a way in which we can use this in the real world. I mean, that's just not, it's not sophisticated enough or something. If people saw us drawing real lines all the time to get an answer, they'd laugh at us. They think we're babies. Oh, you're not with us today. Okay. So we'll just go to the rules for addition. Here, now, I know you'll like that. Rules for addition. This is much more left brain, much more sophisticated. You can talk about it at cocktail parties and so on. All right, there are 2 rules. It depends on whether your numbers are both the same sign or not both the same sign. So Case one is numbers with same signs. Could be both positive or both negative. Here's the rule. Add the absolute values. See, this is becoming sophisticated already. Now we're talking about absolute values. Add the absolute values and attach the same sign, the common sign. Okay, well that's pretty easy to do. Let's make sure it works. Here's one with the same sign. All right, the absolute value of 3 is? 3. The absolute value of 2 is? 2. 3 plus 2 is? 5. Attach the common sign. Well, the common sign is they're both positive, so it gets a positive sign. We never write positive signs. It's just understood if it has no sign, it's positive. All right, let's try this one down here. Okay, the absolute value of minus 7 is? 7. Absolute value of minus 3? 3. 3 plus 7 is 10. Attach the common sign, the negative sign. Hey, it works. Amazing. Okay, case 2. This is numbers with opposite signs. One positive and one negative. And it doesn't matter what order they're in. Here's the rule. Subtract the smaller absolute value from the larger. And attach the sign of the number with the larger absolute value. So this is a longer set of directions than this one is, but you do have to follow the whole thing. An example would be this right here. Here we've got mixed signs. One's positive, one's negative. Okay, it says subtract smaller absolute value from larger. Well, the smaller absolute value is 1. It comes from this over here. Subtract it from the larger. So that's 3, take away 1 is going to be 2. Then attach the sign of the one with the larger absolute value. The one with the larger absolute value is positive. So, therefore, it's a plus 2. Suppose we have something like this. All right, subtract smaller absolute value from larger. That would be subtracting a 3 from a 7. That would give you a 4. But the one with the larger absolute value is that minus 7. So you take its sign and attach it. And there it is, minus 4. So it works. Basically, with this situation here, case 2, the way I like to think of it is this. The number with the larger absolute value is the number that's dominating this situation. You've got a 7 here, but the 7 has the minus sign, and it's a heavyweight compared to 3. Therefore, this minus 7 plus 3 is going to be dominated by the 7, which has a negative sign. So you've got more negative than you have positive. Therefore, the result's got to be a net negative. And that's what this is. Attach the sign of the number with the larger absolute value. This one is the dominant number. That's this one. Okay, let's do several examples of this until we get used to it or get tired of it or something like that. Bless you, someone's allergic to negative signs. Huh? Okay. Minus 5 plus or minus 3. What's the case?
Smaller.
Negative
What's the case?
Oh, adding negative.
two. Case one.
Case 1. Okay, yeah, same signs. Okay, so you add the two absolute values, give you 8, attach the common sign, minus 8. Right? See, no arguments, no, well, I don't think so, none of that. It's minus 8. Okay? The rules are the rules. By the way, these are the two most basic rules of arithmetic. This is it. Everything else in arithmetic depends on these two rules. So should you commit them to memory? Yeah, you should. You say, oh no, subtraction is different. Nope, nope. What we're going to do with subtraction is convert it to addition of the opposite. So we're going to go back to addition, right? What's multiplication? Repeated addition. What's division? It's a form of multiplication. Everything goes back to addition. So this is it. This is the core of arithmetic. Can't get more basic than that. Let's do some more. Suppose we did minus 12 plus or minus 37. Case 1. Case 1 says add absolute values. That's going to give us a 49, right? Common sign, minus. Okay. Let's do some of the next ones. Minus 6 plus 24. Different signs, case 2, huh? Okay, so we subtract smaller absolute value from larger to get 18. Attach the sign of the one with the larger absolute value, positive. Positive is never written, so we do it like that. Okay. Case 2. Subtract smaller absolute value from larger, which is going to be 8 minus 8, which is 0. Attach the sign of the one with the larger. Well, there isn't one with the larger. But that doesn't matter because 0 doesn't have a sign on it anyway. Now, notice what this says is that any number added to its opposite gives 0. We just did it for 8, but it's true for any number. Okay. And just when you think you got it all, let's do stuff like this. Okay. Well, there's nothing but addition there, strangely enough. Those negative signs have to do with negative numbers. All right. We could go left to right. That's fine. That's one way to do it because math does go left to right. All right, let's just look at these two. We don't have tables, for adding 3 things, so we're going to do 2 at a time. All right. What does that say? Well, they've got opposite signs. That's case 2. Subtract smaller absolute value from larger, that gives you a 6. Attach the sign of the one with the larger. Okay, now we've got a case 1. We've got same signs. Add 2 absolute values, 6 and 16, and attach the common sign. So the answer is minus 22. Okay? Should we do another one of those? Why not?
Yeah.
Minus 30 plus or minus 12 plus a 4 plus or minus 10 plus 6. Now, most people find this case 2 to be the more difficult instruction because it's got more to it, so to speak. So they would prefer to do case 1s as often as they can and minimize the case 2s. You can do that here. And the way you do it is you say, well, I've got 1, 2, 3 numbers that are negative, and I have 2 numbers that are positive. What if I put all the negative ones together? Then I'd be doing all case 1s, right? If I put all the positive ones together, I'd be doing all case ones also. Maybe somewhere in there I'd have to do one case two or something. You know? It's just a strategy, right? How to minimize your work to keep the brain alive and well and so forth. Well, can we do that? Can we put them all next to each other? Well, it's addition. Addition has commutative law, has associative law. In other words, you can play around with addition any way you want. So let's do something like this. Suppose I commute these two, meaning I just interchange their places. Then I've got all the negatives next to each other, right? So I've got three negatives. Okay. And that means I use the case one situation, which means I add the two absolute values, but I'm going to just add that to this, so I might as well just add all three all at once. 30 plus 12, 42, and 10 is 52. Attach the common sign. Over here, this is easy, 10. So we do have to do one case one in there. Okay? And that means we subtract smaller from larger to get a 42 and attach the sign of 1 to larger. So the whole thing comes out to be a minus 42. Strangely enough, I know what you're thinking. You're thinking, I have this expensive calculator I bought. So, okay? Why are you telling me how to add things when I've got a calculator? Believe it or not, what we just did there is good for calculators too. Because what you're going to find with your calculator is if you want to enter a negative number, it takes two button clicks, not one. Okay? So if you did this, here's what you'd have to do for this. You'd have to put in 30, and then what's called a change sign button. And a change sign button, unfortunately, can take many, many different forms. You could have CHS, some calculators, that's change sign. A very common one, unfortunately, Texas Instrument, is that, which looks exactly like subtraction, but it's got parentheses around it. But it means change sign. Could be this. This is a kind of interesting one. That's a change sign button. So they get creative sometimes. Okay, so 30, change sign, plus 12, change sign, plus 4, oh, sorry, we need a box for the plus. That's a button. And then another box, plus 10, change sign, plus 6, and then finally equals. That's almost not worth doing. I mean, really. But that's what you have to do if you're dealing with negative numbers. So, saying I'll do it on the calculator, well, yeah, if you got the time. It's easier to do it without the calculator. Strangely enough, we've taken, we run time tests, and you can get it done quicker without the calculator. It's really amazing. All right.
Did you decide after the numbers?
Change sign after. Well, yes. That's not always true. It depends on the brand of calculator you have. I'm not looking at yours now. Then put it before the number. Find out if it works there. All right, now what do we do with these? Remember these decimals? Well, yes, there are negative decimals, that's for sure. Now this becomes kind of an interesting thing, because we're doing addition, right? That's still addition. First number is negative, the second number is positive. Okay, that throws us into a case 2, which says, subtract the smaller absolute value from the larger, which means I'm going to end up, first of all, doing a subtraction, not an addition. And I'm going to be doing this, 4.81 minus 2.73. That's smaller absolute value subtracted from the larger. The absolute value of minus 2.73 is 2.73. And of course, that's just 4.81. So we borrow and do our usual thing. Okay. 1.18. And we attach the sign of the one with the larger,
Oh.
which is positive, 1.18. Yep.
Oh, that's wrong, it's 1.08.
1.08, thank you.
Yeah, you're welcome.
Hmm?
2.0.
2.08, all right, I better get my calculator. 2.08.
Yeah.
Okay. So, using those two rules sometimes is a little bit surprising, like that, the decimal calculation. Let's do some fractions with it. Suppose we have -6/11 plus a -3/11. And once again, I'm putting that -3/11 in parentheses so those two signs won't be next to each other. Okay, we do have same denominators, thank goodness, so we don't have to get a common denominator. So all we deal with is the numerators. So if we transfer this into a -6 plus a -3, what are they? They're 11s.
11.
Just put them over the common denominator, so that works quickly. But again, we're back to the rules for addition now, but of the numerator. And they are the same sign, so you add the two absolute values, which is going to give you a 9, attach the common sign, and you get -9/11. Let's try one where we have to actually get an LCD. 2/15 plus or minus 4/5. Okay, let's go to the LCD. That's usually the first thing that's done. Least common denominator for 15 and 5.
15?
15. So this has the LCD. This has the LCD. We don't have to bother with it. But we have to change that to the LCD, which means we have to multiply by 3 on the bottom. So we get 2 15s plus, that would be a minus 12 15s. Okay, now we've got opposite signs, and opposite signs say subtract smaller absolute value from larger. Well, now that we've got the same denominators, we can actually tell which is smaller and which is larger, because all we have to do is look at the numerators. You got 2 15s, and then you've got the absolute value of this would be 12 15s. So the smaller would be 2. So you subtract the 2 from the 12 to get a 10 15s, and attach the sign of the one for larger, which is reducible to minus 2/3. Minus 2/3. Let's take some English and translate it into math. It says, this is the English that they give us, the sum of minus 14.1, 8.7, and 12.9. All right. Now, that word sum does mean add. So we're going to add these three things together. Okay. Well, the two positives are next to each other, so we don't have to do that. That's already there. We can add any two we want. That's totally up to us. I suggest that we do these two first, because they not only have the same signs, but they're going to, the total of these two will be bigger than this one, which will make it only one of those case twos. All right, so we add them up, 12.9 and 8.7. Okay, that gives us a 16, carrying, that's going to be 21.6. So we got this now, minus 14.1 plus the 21.6. Okay, smaller absolute value from larger, 21.6, subtract 14.1. 7.5. And attach the sign of the one with the larger, which is the 21.6. So this comes out to be a positive 7.5. Remember, minus 1/6 added to 2/3. Well, that's pretty obvious, that's an addition problem. So it looks like this. Now, once again, the recommendation is go to the LCD to begin with, because that way you can be absolutely sure which is the larger and which is the smaller absolute value. If you don't do that, there are times when it's not so easy to tell. They can get numbers very close to each other, but they have different denominators, different numerators, but they're extremely close, and it's not so easy to tell. So you go to the LCD. It's going to be 6. This one's fine, leave it alone. And you can convert that into 6. Well, the multiplier would have to be a 2 there. So you multiply the top by 2 to get 4/6. Okay, now we have two opposite signs, so we go to case 2. Subtract smaller absolute value from larger. So we're going to take 4/6 and subtract 1/6 from it. And since you have the same denominator here, it works very easily. 4 minus 1 would be 3/6, if you recall 1/2. Okay, so the result is 1/2, but we have to attach the sign of the one with the larger absolute value, that is the 4/6. So therefore, it is a positive 1/2. And all of that has to be taken into consideration. There's a lot of thinking that goes on behind a simple calculation like that. You can do fractions on most calculators. They do have a fraction button. But you have to combine that, of course, with your change sign button and so forth. So it gets to be a bit of a pain. Let's see if there's some others we should do here. Let's do another one of these long strings of things. Okay. Let's use a strategy again. Let's get the positives next to each other, the negatives next to each other. In order to do that, we have to do a couple jumps, not a big deal. What we're going to do is interchange these two and then interchange those two. So it'll end up looking like this. Basically, you can play hopscotch with these things. Minus 12 plus a minus 30 plus a 4 plus a 16 plus a 10. Okay, these two together, same sign, add the two absolute values, 42, attach the common sign. Now these three together, that's going to give you 20, 30, and attach the common sign, which is positive. Now you have to go to a case 2. Case 2 says subtract smaller from larger, 12, but attach the sign with the larger. So it goes very quickly.
Can you do one from translating the English phrases?
Sure.
Maybe number 88?
88?
Mm-hmm.
Okay, a total of 3 minus 10 and 5. See, the words for addition are pretty easy. You know, most people say, okay, I understand total means addition and so forth. When we get to subtraction tomorrow, that's when things get nasty with the English. You have to be careful with that. Okay, total of. So that means we're adding 3 plus a minus 10, parentheses, plus 5. Okay, we can commute if you wish, and then you get this, which allows you to do a case 1 here to get 8, and finally a case 2 here, which is 8 from 10 is 2 with a minus sign. Okay? When you get into the practice of it, it goes very quickly. Just do some problems for homework and you'll see. So, we're in section 10.2. This is, this one right here is a calculator connection, which means you're supposed to use your calculator to find out how to use the